Here is a giant fictitious molecule, but it has a lot of different shapes, so let's talk about them. Let's start at the top and work our way down. Here you have a xenon atom with 4 atoms bonded to it in 2 unshared pairs. By electron geometry, it would be an octahedral shape. You have 6 things sticking off of it, but however, 2 of them are unshared pairs. So it only has a square planar shape, is what you would call it. The bond angles would be 90 degrees between each of the atoms sticking off of the xenon. It would have an sp3d2 hybridization because it has 6 things sticking off it. When I say things sticking off it, I mean atoms bonded or unshared pairs. If you look at this nitrogen right here, you can see you have 2 atoms bonded to it, and you have an unshared pair on it. That nitrogen then is going to have a bent shape, because if this unshared pair wasn't here, and it was just 2 atoms coming off the nitrogen, you'd end up with a linear shape. However, that unshared pair causes repulsion and pushes these to a bent angle. So you're looking at about a little bit less probably than 120 degrees, and it would have, since it has 3 things sticking off of it, then you would have an sp2 hybridization. If you look at this oxygen right here, you can see that you have 2 atoms bonded in 2 unshared pairs. Again, a bent shape, and you have a bond angle of a little bit under 109.5 due to the added repulsion of the unshared pairs. They repel a little bit more than atoms that are bonded because they sit a little bit closer to the atom. Over here, we have a phosphorus. You can see 3 atoms bonded and 1 unshared pair. So that's got 4 things sticking off of it. So it has a hybridization of sp3. You would say it's electron geometry, which is when you look at all the different regions of electrons around it, would be tetrahedral. However, you get a trigonal pyramidal shape. Over here, you have sulfur with 4 atoms sticking off of it, and you have an unshared pair. So you would have an sp3d hybridization, and you would end up with a seesaw shape. You don't need to worry about the bond angles on that. On this phosphorus right here, you can see there are 5 atoms bonded, so that would need 5 hybridized orbitals. So you'd again have an sp3d hybridization, and the shape around that would be trigonal bipyramidal. Scrolling over here, we have nitrogen, 3 atoms bonded, 1 unshared pair. That again would give you a trigonal pyramidal shape. Bond angles a little bit under 109.5 because, again, unshared pairs repel a little bit more than atoms bonded. If you look down here at this carbon, you can see that it has 3 atoms bonded to it, but this time there's no unshared pairs. So you end up with a trigonal planar shape with a bond angle of about 120. And since there's 3 atoms bonded, no unshared pairs, you'd have 3 hybridized orbitals, so it would be an sp2 hybridization. And if you look down here, this has kind of the same situation. 3 atoms bonded, no unshared pairs on the carbon, so you have trigonal planar. Trigonal planar, by the way, has a bond angle of about 120 because that's about as far as 3 things can spread out from each other around an atom. And I think I've covered everything on here that I wanted to. I hope you enjoyed it.